Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class, and today we are going to be treating heat energy part 2. By the end of this lesson, you should be able to explain specific heat capacity by method of mixture, and you are going to solve a few problems on specific heat capacity. Now, when we are talking about method of mixture, remember that in the last class we treated specific heat capacity, and we stated that it is the quantity of heat needed to raise the temperature of a unit mass of a body by 1 Kelvin or 1 degree Celsius. Then we now talked about the fact that this specific heat capacity is the nature of a substance. So specific heat capacity are constant. They are unique to different bodies. So that of water is 42,000 joules per kilogram per Kelvin. So when we're talking about specific capacity, we are really talking about the amount of heat energy that the body is able to carry in moving its temperature from 1 degree Celsius. Now, there are different ways of finding this specific capacity. Number one is method of mixture. Method of mixture. When we're talking about method of mixture, we are talking about you being able to heat. Now, look at this scenario. Let me paint this picture. You remember that when you want to bathe water, for example, is common. You want to bathe a warm water. Then what do? You get a cold water and then boil water to a certain temperature, like let's say 40 degree, no, can't be 40, it should be around 80 degrees Celsius. You now pour it inside your bucket you want to use to bathe, depending on the facility you have. Then some other people may not do that, they will just transfer it from the heater just to the bucket. However it does, what you are doing is mixing the temperature of one substance with another, and that is also what is happening here. And that is also what happens here when this mass was lifted and dropped inside. Here. Just look at what happens here. Now this body of mass is heated. After heating it, what happens? Then this is a calorimeter. Then it is lifted and put inside that calorimeter with the water. You see the temperature of the body will increase. So what has happened here is that a mixture has occurred, and such mixture has led to the increase of one substance gaining heat and the other substance losing heat. And that is the same thing I was explaining. When you mix water, maybe the one in the bucket, the cold water, is going to gain heat, while the one that is hot is going to lose heat. It's all about the method of mixture, which is an adopted method of finding the specific heat capacity of a substance, whether it's liquid or solid. Now, the first thing we're going to look at is measurement of specific heat capacity. Measurement of specific capacity by method of mixture. Now, there are a lot of things your textbooks have written, and look at the formula, the mass of this and that. This is a pure laboratory experiment. But however, I'm going to show you the principle you are going to adopt when you solve problems on them, even when you don't have to go and cram. You don't need to go and start cramming this formula or trying to memorize them. I'm going to show you steps on how you can follow to be able to find the specific capacity of any substance by method of mixture. So let's get to it. Now, what I'm also showing you is also what you've seen before. This is a body and is heated to a particular temperature, is transferred inside a calorimeter. This one is a copper calorimeter, and the temperature of the two of them will mix together, and then we have a final steady temperature, which we are going to use for our problem. Now, we are starting with the first one. It said a metal of mass 200 grams at temperature of 100 degrees Celsius is placed in 100 grams of water at 25 degrees Celsius in a container of negligible heat capacity. If the final steady temperature of the mixture is 30 degrees Celsius, calculate the specific heat capacity of the metal. Then they gave you specific capacity of water to be 4,200 joules per kilogram per Kelvin. So what I am going to do here is going to list the steps you are going to follow. Each time you are given this kind of question, such that a body is mixed with another body, that is method of mixture, you are going to take this step. Step 1 is going to be identify the substance. Identify the substances used in the question. Now look at this question. What are the substances used? Number 1, metal. So we have metal. Another one is water. And the last thing is container. These are the substances. So I have identified them. That is step 1. Step 2, what are you going to do? Write the quantity of heat of metal, the quantity of heat of water, and the quantity of heat of the container. However, in this question, the container is of negligible heat capacity, so I'm not going to bother myself with that because it's negligible. When they say negligible, it means that it does not really matter. It was not taken into consideration in this question. So now, remember the formula for quantity of heat. The quantity of heat is given as Q MC change in theta. Now I'm going to write this for metal. I'm going to write this for water. So let me remove this because it's not part of our problem. And that is simply modeling this general formula to suit each of these substances. So I'm going to have quantity of heat for metal is going to be equal to mass of the metal, specific capacity of the metal, and change in temperature of the metal. Then I'm going to also do that for water. So mass of water, specific capacity of water, and change in temperature of water. So these are the two quantities of heat given, and this is what I do in my step 2. So what do I do in step 3? In step 3, I will now start putting in these parameters in order to solve this problem. So let me So quantity of heat for metal is, what is mass of metal? The mass of metal is 200 grams. I will convert it to kilogram, and I do that by dividing by 1,000. Now, what is the specific heat capacity of the metal? What is it? Let's look for it in the question. It said calculate the specific heat capacity of the metal. So is what I'm looking for. So I'm going to call it Cm. That is just my choice of parameter. Then the next thing is change in temperature. Now what happened? Look at what happened. Let me show you. Now look at what happened. This is heated, just like the question is telling us. This is heated, and the temperature was recorded to, let's say, 100 degrees Celsius. See what happened? Now, it's now carried and put on the hook and transferred inside that container. So there is water inside the container, and the temperature of the container and the water and the metal will increase. What happened at that point? This particular mass has lost quantity of heat, while the water inside this container has gained some heat. So this is just what happened in the question we are looking at now. So then the temperature was heated to 100 degrees Celsius. Then when it was transferred inside the container, a new temperature is formed, and that is the temperature, the steady temperature of the mixture. and that is 30 degrees Celsius. So the change in temperature for this metal is going to be that 100 degrees Celsius minus the temperature of the mixture, and that is going to be 100 minus 30 degrees. So I'm going to have this cancel, this cancel. I have quantity of heat is going to be 2/10 times specific capacity times 70 over 1. This will cancel this. I have quantity of heat for metal is going to be 2 times 7 is going to be 14 cm. This is the quantity of heat for the metal. I am done with that of the metal. Remember, I'm still in my step 3. Step 3 is where I put on my parameters, please. Now, I'm going to do that for water. Now, this is the quantity of heat for metal. For water, the quantity of heat for water is going to be, what is the mass of the water? The mass of water is given there as 100 grams. I will still convert it to kilogram by dividing by 1,000 times specific heat capacity of water is already given here as 4,200. So I'm going to put 4,200 times what will be the change in temperature for the water. Now remember that you can't carry water on your hand. It must be inside a container. So the temperature of water will still be the same temperature of the container. And then at the end, what happened was that both the mass of the substance, that is the metal, and the water, all of them are put together in one place. That is why we call them method of mixture. So at the end, a new temperature is formed. And that new temperature, they will use different language for this. They may say final steady temperature, or they may say temperature of the mixture, or they may say the steady temperature. And that is given as 30. So what you are going to do is temperature of water minus temperature of the mixture. And then the temperature change must be positive. So you are not going to say 25 minus 30. That is going to give you a negative value. So let us remain with a positive difference of the temperature. So that is going to be 30 minus 25 degrees. So I'm going to have this cancel, and this will cancel this. So I have that quantity of heat for water is going to give 4,220 all times 5. And this is going to be 0. 5 times 0 is this. 5 times 2 is 0, carry 1. 5 times 6 is 20. 21 joule. Now, this is the quantity of heat the water was able to retain. Now, I am done with step 3. The step 4 I'm going to do in this case is to apply the principle of conservation of heat, which says that heat is neither destroyed nor created, but can be converted from one form to the other. So when the metal was heated and dropped inside the container, the heat energy of the metal is given to the container or water, and why the water gain it. So the last thing I'm going to do here is that heat gain is equal to heat lost. So heat gain is water. The water, look at the quantity of heat that the water gain, which is 2100, and it's going to be equal to the quantity of heat lost, and that's going to be 14 cm. So if I make the specific capacity of the metal the subject formula, I'm going to have this. Okay, this 15. So Cm is going to be 150 joules per kilogram per Kelvin. This is the specific heat capacity of the metal. Now we are going to, we've talked about this issue of heating in our previous lesson, but I'm going to use what we discussed in our previous lesson to solve the problem of this kind. This is a problem on latent heat. So what is the total amount of heat energy required to convert 0.5 kg of ice at minus 15 degrees Celsius into steam at 100 degrees Celsius? Specific capacity of ice 2100 joules per kilogram. Specific heat capacity of water 4200 joules per kilogram per Kelvin. Specific latent heat of fusion 3.36 times 10 raised to the power 5 joule per kilogram per Kelvin. Specific latent heat of steam 2.26 times 10 raised to the power 6 joule per kilogram. Now, this question, I am going to use it to further buttress what we learned in our previous class concerning the heating of a body, because for you to be able to raise the temperature of a body from minus 15 degrees Celsius to 100 degrees Celsius, it is all about heating or gain of heat by a body. So I'm going to use this illustration. Let's assume that this is that 15 degrees Celsius, minus 15 degrees Celsius. So what happens? The temperature increases to 0 degrees Celsius because this place is 0 at origin. And everything there is going to be under temperature, theta degrees Celsius. So, and then this is going to be the latent heat of fusion, because at this point, the body did not continue going up. There was a constant in temperature. And whenever there is a constant temperature, then we talk about change of states. And that is this. So everything from A to B is solid. Whenever it is in this slant pattern, it's going to be change of state, change of quantity of heat energy. But whenever it is constant, we are going to consider change of state. So this is a change of state from solid to liquid. And when it enters here, everything here is going to be water. Then when it gets to 100 degrees Celsius, it's going to also experience another change of state. And before it continues going up, if the temperature is to continue. So this is going to be latent heat of vaporization. And let's see how it goes. So I'm going to label this from A to B, from B to C, from C to D, and from D to E. So I'm going to have mass of ice, specific capacity of ice, and change in temperature of ice. That is going to be the quantity of heat from A to B. And mass is 0.5 times specific heat capacity of ice is going to be about 2,100. Then times change in temperature. Change in temperature is going to be from minus 15 degrees Celsius to 0 degrees Celsius. That is from here all the way to B. And that is going to be 15 degrees Celsius. While because I'm going to say the highest temperature minus the lowest temperature, which is 0 minus minus 15, which is going to be plus 15 degrees Celsius. And that is why I have this. So quantity of heat from A to B is going to be (0.5 times 2100 times 15). 15750. 15750 joules. Now, the next thing I'm going to do is quantity of heat from B to C. Now, it's still going to be the same mass. The mass is going to be 0.5. This is M, mass of the ice, times this LF. That LF is representing, the LF is representing the latent heat, the specific latent heat of fusion. And that is given as 3.36 times 10 raised to the power 5. So 3.36123. And that is going to be quantity of heat of BC is going to be 168,000 joules. All right. Now, if I'm going to find the next one from C to D, the quantity of heat between C to D is going to be mass of water. Remember, the mass of ice does not change when it changes to water. So it's still going to be 0.5 times the specific heat capacity of water, which is 4,200 joules per kilogram per Kelvin. 4,200 times 100. What is this 100? 100 is the change of temperature from 100 degrees Celsius to this, or from this to this. That is the same thing as from 0 to this part. And this is going to be 210000 joules. Now the next quantity of heat we need is going to be between D to E, and that's going to be because at this point now is a change of state. It's going to be mass of the body, which is 0.5 times the specific latent heat of vaporization or steam. Sometimes they call it specific latent heat of steam, which is 226 times 10 raised to the power 6. So 226 6 zeros, 1, 2, 3, 4. That is at that point. So have this 1131234 joules. Now these are the stages the body went through before it became 100 degrees Celsius. Now let us add all of them. I'm going to add the first one, which is 15750, plus the next one 16800, then plus 210000, then plus this one, which is 111, that is 113 1 2 3 4. I'm going to have, now I'm going to use another word for this. So total energy is going to be 1523750 joules. This is the quantity of heat needed to change the ice from minus 15 degrees Celsius all the way to 100 degrees Celsius. Thank you for being part of this class. But before we go, we are going to take a few more exercises from Examguide app. Let's go. Calculate the temperature change when 500 joules of heat is supplied to 100 grams of water. Specific capacity of water is this. So the quantity of heat is given as 500 joules. Then the mass of the body is 100 grams. Then what I'm looking for is temperature change, and specific capacity of water is given as 4200. So change in temperature is unknown. So I'm going to apply this principle, MC change in theta. 500 is equal to 100 times specific capacity is 4200 over 1 times change in temperature. This will cancel this. Then this will also cancel this. We now have that change in temperature is given as 50 over 42. And that is given as 50 divided by 42, 1.2 degrees Celsius. And that is seen in option A. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.